And we're back to our constraints. So with the main constraint, I guess that I'm gonna leave it like it is because, you know, stiffness 10 is fine. We want to break those constraints pretty fast, so I don't need to increase the stiffness now. Now inside constraint, so let's decrease the strength even more, like 0.1. They should break very fast. I don't need to have a big strength for them. But also I want to add the plasticity for this. And the angular stiffness, let's turn on just position only. I don't want to have any angular, so it's just now controlling the position. So we have just a stiffness and damping ratio. And with plasticity, let's keep threshold like 0.1, but increase the rate. I don't know, like 10. And for hardening, let's set 50 for the plasticity. That's actually it. I guess that it should work for our inside constraint. And let's do the same for all other fragments, for all other constraints. So yeah, another one thing, it's a very important thing, I forget to talk about this, I forget to say, is we need to add the name of those constraints. So we create constraints for other group, for other fragments, for those small fragments, and not set the name for those constraints, okay? So we apply those settings for all constraints inside of this node. So all elements which go here, they will have those settings. So before we do this, I want to before I connect those elements to RBD simulation, I want to name those constraints. Let's say other constraints. Okay, let's keep setting the same. I want to copy and copy it here with the settings again, strengths like 0.1 and change the position only. I guess I don't need a plasticity here. Okay, and I will resave it later a little bit because it takes some time. So I just save this. Okay, that's worked. Okay, the next one is our antenna. The main constraint is soft, keep the same inside constraint. Let's add, or for main constraint, let's do one interesting thing. For the antenna, let's increase the stiffness to like 100 or even more, like, I don't know, 300. Oops, sorry, 300 to have a big stiffness. I don't want to break those elements too much. So like 300, it should work. And the same for inside constraints. Let's increase, make glue like 0.1 like we did. And for the position only, let's add a stiffness like, I don't know, 100 for the elements inside, and enable plasticity 1050 like we did for our main fragments. You can keep it. Again, the last one is gone. Let's increase the stiffness also, maybe to 100, not too much. Okay, 0.1, position only, and let's say stiffness 100 and 1050 like we did. Okay, now I want to resave this again because I want to have a name for other constraints, and also I want to have a new settings for constraints right now. I'm gonna keep all this what we have. Now those constraints between, as you remember, between our main fragments and the other. So let's increase the stiffness to like 50. Okay. Let's set strength to 1 for the glue. Some metal to static, as you remember. Okay, and I'm gonna have a new RBD cache for this. So I make a pause and I want to cache those all those elements again. All right, so I save this file, actually all those files. So now we have a different constraint setup. Visually they're the same, but we have a different settings here. If you go and look, you can now see that we have a damping ratio, and we have, what else? We have a position for the soft constraints. All right, we have a plastic rate, which is 10. We have a plastic, what is hardening? Yeah, 50. Okay, so we save and this works. Yeah, I need to save it again to my temporary file because we have different constraints. And I guess that just in case there is some changing, I want to recache this also. I'm not changing small fragments, but anyway, just to make sure this all the same, I want to save it again too. Because I know sometimes there's a small changing. If those guys won't match, you know, maybe the name or something won't match between them, constraints will not work properly. That can be a big problem in our case. Okay, that's saving now. So with bullet, I guess that I will, what I want to do, I will remove my blast from cluster, so I don't need to use this. Yeah, I guess that I will connect it like so. And RBD configure, yeah, I'll save it again. Let me double check my RBD configure. Am I right here? So time, old name, yeah, all this thing here works fine. Metal still. All right, so I resave my small frags again with all clusters. And let's see how this explosion works with new constraint settings and with the full body of the ship. Let's go to scene view. And again, sometimes it can cause crashing Houdini, but I hope that it should be okay in this this time. When I worked in this scene last time, before the training start, I remember that the RBD bullet solver crashes, I don't know, like 30 times, something like that. And what is the most bad thing in this story is that it crashes even without auto-saving. Sometimes, in many cases, Houdini, when it's crashing, is creating the temporary copy in the temp folder, and we can restore this information from the file. But I don't know why with RBD bullet solver it's crashing without saving. So all the information from your last save will be removed. But I saved this file just in case it's gonna happen. So another thing in RBD bullet solver, maybe I want to change something. Let's go to the setup. Don't need to use the gravity. And with the air resistance, maybe I want to increase the resistance a little bit bigger. So let's set it 0.0, I don't know, maybe 1, something like this. Ignoring the mass, add drag spin, and drag spin resistance, let's say 0.01 also. So we're gonna have the same settings for the resistance. With the bullet object, let's just keep like it was by default. Maybe we're gonna change it later. Let's go to constraints. So the breakable is the main constraints. So you can see there is two types, inside constraint and main constraint. We choose main, that's correct. Impact, advanced. And in advanced, maybe let's choose a randomized constraint order, and cache memory, let's increase a little bit of caching. Okay, let's look at this for now. Let's select RBD bullet solver. Let's choose the camera, and I want to create a simple animation. So create playblast, or in this case, flipbook. And now let's start from frame 23. And let's look at the result of an explosion. And it's still pretty big, but anyway, what I want to do is fixing some problems we have. We can see that our ship is falling down, and that's one of the main problems in this case, because in real world is on the water, and water will push up the ship. And in our case, with an explosion, we can simply look at the velocity. You can see that we have pretty high values here, and we can go inside of the RBD bullet solver. Let's change it to manual to avoid any recalculation again. And we can play with the maximum distance, like 10 maybe, and explosion scale like 2, I don't know, just 3 or 3, something like that, to avoid very, big values here. Let me double check that I'm right here. Yes, I have a fit, is correct. Okay, multiplying. Yeah, I guess this works fine for me. Near point, get position, get velocity. Yeah, this all works. All right. So how we can keep this ship in a position? How we can keep the ship under the water? How we can do this? And there is a very good option in the RBD bullet solver, and an option called guide simulation. How this guide simulation works? Well, here is a very interesting example in Houdini help. If you go there, in any case, it's very helpful to read the help for the RBD bullet solver, because there is a lot of interesting information here. There is some text. You can find out how this works, the collision option, all this stuff. But behind all this thing, we have an interesting examples. So if I want to look the guided RBD bullet solver, I want to launch the simple example from the side effects guys. And here's an example. So there's very interesting examples, and it's a really cool feature. So this example demonstrates a low resolution simulation driving a high resolution RBD guided simulation. So many of my students ask me how we can apply the high quality resolution to the low resolution simulation. And that's where our guide simulation can help us. So there is a few different fragmentation. The one is with the high quality edges, and another one just simple the RBD with Voronoi, and using the RBD bullet solver they create a simple simulation, so those elements just fall down. Now we can apply this animation to our high-res fragments, and it's simply doing by the guided geometry. So you can see this blue fragments because we have visualization here show guide blue. In the guide simulation we use guides. Well, there is some VEX options, but the main idea is we drive those fragments. You can see that they slide like big chunks here. So we transfer the big fragments movement to the low resolution elements. And we have some option which allow us to release those elements from the guide geometry depending on the thresholds. It's linear threshold and angular threshold. And you can see that after some hitting, you can see that some fragments became black color, so they're not guided geometry anymore. They will fall down as a simple geometry. Also in the bottom area, so you can see that some of those geometries will go from the guide geometry and some of those still guided. So those elements we have the same animation like a low-res simulation, but with the high-res part elements. And this is a simple example. This is animated guide sim. This is a little bit more difficult. Is demonstrate animation geometry to drive a guided simulation. So let me escape, holding escape to avoid calculation. So now if you go here, press play. What we will have, stop it. Okay, where is our geometry? Okay, here we go. This is our box. And we have two elements, like two boxes with the bending. You can see that they became like so. And that's how we can create some kind of breaking elements. If you play, why it doesn't work? It doesn't show me somehow, I don't know why, but it should work. Display geometry. Back to frame 1. Not see anything. That's interesting. Why? They should break this geometry into parts, but somehow it doesn't work for now. Maybe I want to use a manual update. That's interesting. Why it doesn't work? It should work. I don't know what's happened, but I'll launch this again. It's typing something about cache problems. Okay, so if we have a two bending, yeah, you can see that something is wrong. Icon cache, I don't know what's happened this. Yeah, something wrong with this element. Anyway, we have a bending for those elements, and now we transfer this bending to our fragments. And it's create a very interesting result, like slicing the element, breaking into two parts, and they just fall down. It's really cool. It's really cool. In fact, using the guide geometry, you can create a lot of animation for our fragments, and it's not driven by the forces, it's driven by different geometries, and it's really cool, and it really can help in many situations. So yeah, something wrong with that. Anyway, our file is good and we keep working here. And in this situation, our guide geometry can help us to keep our ship above the water surface. It can help us. And how we can do this? We can take our ship geometry and use the geometry as a guide element. And again, if we have a fragments which will fly away because of the explosion, they will go from the guide objects, they will release it, they will be released using those thresholds, and they will fly away like under the gravity stuff and all this thing. Because I can disable the gravity and our ship is stopped falling down, but our fragments is also won't go down. So that's what I don't need to have. And another one thing important is that I want to create some kind of animation. And what animation I want to use? Go to the ship import. Oh, actually, let's create the separate file. Let's call this. Select geometry, and let's call this file like a ship animation. And what type of animation I want to create? I want to create like ship is going up a little bit and break into parts after the second explosion. Sorry. So we have two explosions basically. The first explosion is on frame 25, and all other explosions we have on frame like 46, 47, and 49. Yeah. So it's like a huge explosion, the second one, and I want to break this explosion will break the ship into two parts, and the ship is rise up a little bit, you know, because the explosion going from the bottom of the ship and it will push the body of the ship up. So how we can do this? Let's select our, now I don't need explosion. I need to select my ship, which is here, the out geometry. I don't need to select all ship elements, the guns and all that stuff. I just want to take my main body, and I want to put this main body here to the ship animation. So using the object merge node, paste here. I want to switch to the auto update. Let's wait till it will load here. Let's rename this like main body. And the thing is, my second explosion should be somewhere here in the middle of the ship, and I want to break the ship into two parts, in the front and in the back part, and then create an animation like it bending or moving up. How we can do this? Well, if you want to break this element or if you want to break the ship into two different parts, the first thing I want to do, I want to add a transformation node and put the ship straight to the x-axis. So I want to rotate this, I guess, to 20. Oh, no, not you, sorry. No, come on. No, the wrong axis. And the last. Okay. So I rotate it, yeah, y-axis, sorry, I rotate this ship to make it, you know, linear. So now it's look straight to the x-axis. And now let's add the group node. With the group node, we can simply take our points and using the bounding box, let's make it bigger. I already know the size of those bounding boxes, and -68, I guess. I don't remember exactly, like this. Yeah. All right, so I take the front of the ship, let's call this front points, and then I will transform them back to the position. So invert transformation. So now my ship in the same position like it was, but now with the group calling front, all other elements on the another group. So if I type blast and say that, okay, let me remove the front group from primitives. Oh, sorry, from points, not from primitives, from points. So we have the back side of the ship. All right, and if I use another one blast with delete non-selected, I will have the front side of the ship. So we're gonna pack those guys. All right, so I want to have just the 2 points. When I pack in geometry, I have just 1 point, 1 primitive, 1 vertex, and all this thing, just 1, 1, 1, 1, 1. And that's a little bit easier to animate. Let's merge them. Let's, I don't know, to make it more visually better. Let's merge. Come on. So now it's still the same ship. And what I want to do is create the animation. So let's add a transform node. Come on. Let's select the group. I have just one group, I guess, right? I have just, hey, where's my group? Oh, yeah. I forget that I packed this object, so let's create the groups again. Let's create the groups again. So let's select, so this is primitive, let's remove this. Group 1, so if I blast my primitive, you can see, so my nose is primitive 1 and my back is primitive 0, yes. So we can use this. So if, now let's type my prim num will be equal to 1 is should have the attribute, let's call this ship part. It's a string attribute and it will be front. Okay. Now if the primitive number is 0, that you will have the attribute back. Okay. So now if you go to jump to spreadsheet and go to primitives, come on, we have pack1, pack2, and yeah, we need to switch to primitives, sorry. And yeah, we have a back and front, cool. So now it's transformation node. What I can do is select or just type here, if I want to create animation from the front part, I can say that if my ship part attribute equal front, then when I move this element, you can see that I move just the front part of the ship. And copy this transform node. One interesting thing I want to mention about that, some people make mistake, me too. When we copy this node like transformation, holding the Alt key and drag it under this, it looks like we have a proper connection, but it's not. You can see that this second transform connect to the attribute triangle. It's very important to understand and keep in mind that when you do this, you will connect it to the attribute triangle, and this first transformation won't work in this case because it's not connecting to the second one. Because sometimes it can happen that you hurry and try to do something and it doesn't work. So back animation. All right, so now I'm gonna play a little bit with those elements and I will show a result with the animation. Yeah, you can see that we have a whole bit because I removed the points and not the primitives. Anyway, we need just to create animation and that's it. And here what we have, bam, and it's falling down, bam. So that is very simple. I just create a few keyframes. For the front animation, on frame 44, I store this info in frame 52. I push the nose up a little bit and add a little bit of rotation on the X and Z axis, and then put it back and just keep this a little bit upper, so 1.6 on Y axis, so it's slowing down, and I create a curve there so you can see that it's moving up and then slowly begin to fall back. The same stuff with the back animation. On frame 44, I store information. On frame 55, I create a bigger angle so we can see that it's really, I don't know, maybe it's too much because I think that there is not too much explosion force to push this ship such a big, such a big distance and a big height. But anyway, it's looking pretty interesting. If I go to animation camera and I create the flip book, it's looking nice from this angle. Maybe not, like 100 physically correct, but we are artists. FX artists, so bam. And yes, my animation is not my, main job, but it's looking not bad, I think. Okay. But what we need to do, we need to apply this transformation to our main geometry. So we have the main geometry over there. This is my geometry. Okay. And I want to apply this information to this geo. For such a job, we can use the extract transformation node. Well, extract transform, we can apply if you want to create like a fragments with the animated objects. Let's say, you can find on internet, on YouTube, you can find the video, I guess it's called Fracturing Animated Objects in Houdini. It's a free video, so you can find and look how this thing works more in detail, because I don't see a reason why I should do the same to explain you if you can look just for free. Okay, so you can find the way how we can create diffraction for animated objects, and very useful stuff. In our case, I'm going to use the extract transform node to take my original object like this and grab transformation. All what we need to is just compare two objects. This is the reference geometry and this is the target geometry. So what we can do, we can take this geometry, we can store using the time shift node the position for this object. So let's say in frame, I don't know, like frame 25, doesn't matter, before we create animation. So let's press Ctrl Shift and click on the frame, so it will stop the animation frame 26. You can see there is no any kind of animation. So to the first input, I connect my animated geometry, and to another one, my static geometry. And it will compare both objects, and it will store if those objects will be animated. So as a result, we can see nothing here because we need to select which attribute I want to use as a piece, and my attribute is a ship part. Come on, yes, it's my ship part. Now inside of geometry spreadsheet, we have 2 points because we have a packet objects. And now you can see that those points are animated. We have the orientation matrix, we have a pivot points. So that's how we can store this information. And now we can say, okay, how we can use this information. We can transfer this information to our geometry. So if you look here, our geometry, or maybe like here, without, separation. So we can take this geometry and we can apply the node called transform pieces. I guess that you already know what this node doing. It's using to apply the animation from template points to geometry. The same node we have inside of the RBD bullet solver. I already show you how this works. Again, just quickly turn off manual. We have the DOP import with the points to represent objects, and then we use transform pieces to apply geometry to those points. We will use the same method. We're gonna take our original geometry over here and our template points over here and apply the transformation. So now we need to set the attribute, and we know this attribute is ship part actually. Let me check. Yeah. But there is a problem because we don't have such attribute in this geometry. Okay, we add this attribute over here in the attribute wrangle. We take 2 primitives and name them. So now how we can apply the same attribute for all points on the ship? So that's very simple. We have a group, call it front. Let's set another attribute wrangle just for our geometry over here, over the points. So if my points inside of the front group, okay, so let's create if those points in a group, call it front. Okay, so as you know, if we transfer points to the group, we have the attribute called front. Actually, it's a group, call it front. And if those points inside of this group, they have the attribute 1. If they not inside of this group, they have the attribute 0. So when I type if I, because it's integer attribute, group front equal to 0, it means that this point not inside of this group. So then I create the string ship part attribute like we did here on this attribute wrangle, and say that those points inside of the back group. In this case, we say that you will have the attribute back. If not, so if you inside of this group, if front is equal to 1, then you will be inside of the front group. All right, so now we have our, we go to attribute wrangle, and for the points, oh, come on, why it doesn't work? The back and front. Oh, because I need to check out update. Now we can see that we have the ship part attribute, and we select our points or separate our points in two different attributes, back and front. And now with the transform to pieces, when we have the matching, if we have attribute for the both elements and from the points and from the geometry, now we can look at the animation. Let's go. Yeah, but in our case, we need to invert transformation. So make checkbox, and now we have a transformation for those points. So this is now geometry. Our geometry we can use for applying the guided geometry. So let's add another object. Let's set it out. Deformation. Out our deformation. Let's copy that. Let's go to dynamic and let's add this as the object merge. This is our deform ship. Oops, sorry. Our deformation. But in our case, we have a little bit more objects here to deforming. So what I want to do, I want to take my deformation geometry and use this geometry to deform my original geometry, this geometry, to deforming my fragments, okay? Because here just a basic ship without fragmentation, without geometry correction, they have a holes, they don't have a thickness, so this is just my, you know, like a default model with deforming. But I need to take my geometry from here, my fragments, and then apply this deformation to those fragments. We can simply do this by the point deform node. It's a very simple node, but it's really useful and powerful. And we have the two inputs here, which is should be, it's required, and it's mesh to deform. So what we need to deform, I want to deform my mesh from here. And there is the rest point lattice, and the rest point lattice and the deformed point lattice. What we need to connect here, if I connect my geometry to the last input, which is deformed point lattice, and what I need to connect to the rest point. The rest point is like a static position from this deformation. Okay, so again we can take like frame 25 or something else using the same time shift like we did in the last time. Can make a frame 27, it doesn't matter. Connect it, and then we will have, this will be the rest position for the point deform. And now it can compare the deformation between the rest position and between the animated objects, and then transfer this deformation to our fragments. That's what we're doing. I think that we keep all those elements in the same position. So now let's see, does it work or not? Let's go to point deform, and we should have our fragments. I guess it takes some time, but if you go somewhere in frame 53 or something like that, after the second explosion, we should have our fragments with the movement, and yes, it is. So now we're going to use this geometry as the guided object for our main simulation. So let's call this RBD sim. Now we need to say that, okay, what geometry I want to use as a guided object. So you can see that I enable use guides, and there is a few options we can use here. We can select all geometry as a guided object, or we can select just a part of this. In our case, for now, I'm using just my main frags, so I can use all geometry as a guided object. But if I want to merge, the other small elements, I don't want to use them as a guided. So I will separate them into pieces, but I will do this a little bit later. And now when I'm using the guided object, I want to show you another example how we can create explosion inside of the RBD bullet simulation using the fields and the volumes. Okay, so I deselected the geometry warp. Now let me show you another example. And here you can see that we have used the pop forces into force output. So if we want to advect our particles, our points using the forces, we can apply the pop advected by volumes node. So that's a nice thing. I think that it's like a ball from, like football ball from this distance. So connected here. So what we need to have, if we want to use the pop advect by volumes thing, we need to have a volume and we need to have a field inside of this volume. And we can use this field to drive our particles or points in our case. So if you want to create a field, we can back here to our setup for our explosion setup. Come on. Here we go. We have our particles. So what is the advantage of this method? The advantage is we can select and create the volume using those particles and can, drive, create the velocities inside of this volume to drive our particles. So we can select the volume rasterize attributes, okay, and we will transfer the velocity into the volume. So we can type here V, which just means that I want to create the volume based on the velocity. So where you are, go to frame 25 because it exists just on frame 25 in this case. Here we go, here's our volume. So you can increase a little bit the particle scale because I want to create a big volume, or else I want to some explosions animation, maybe reduce the sphere scale because it's really too big in my opinion. So maybe like 7.5, so a little bit smaller sphere because 10 is cover a big part of the ship. I didn't want to create such a huge explosion, maybe like 5 even. So if you compare the ship scale, let's choose my deformed ship, or let's template it, and my particles from the attribute randomize. So now you can see that they already cover a big volume, and it's smaller, 2 times smaller if we back to our ship explosion and type 10 like it was. It's really huge volume. You can see that it's cover very big, even under the ship. I don't want to do this, so it's really big. Let's reduce the size of the sphere, and that's gonna be a much better in this case. All right, so we create the volume from those points using the volume rasterize attributes node. Mainly we use this node for creating fields for the pyro simulation, something like that. But for now, it can create for us a nice field with the velocities. So the voxel size 0.1, we can leave it. In this case, doesn't matter in fact. And we have a velocity fields inside. Cool. So now we can take this velocity field inside of the RBD sim. We can take, well, actually need to copy. Oh, come on. You want to explosion, create explosion. No, guys. Go to manual. I don't want to do this for now. Just wait a few seconds. Copy this velocity out and paste it here on a sub and select the field name called V, not a velocity. So, and I want to update the force, and the force scale, what scale we have here? We have scale 3. So let's type 3 in this case, the same scale. maybe a little bit bigger. Let's type 10 because we create a smaller volume. Yeah, we reduce the sphere size, so our volume is much smaller for now. And let's go to RBD sim. Let me just disconnect this point before this guide object for the moment. I just want to see is we have some difference between explosions using the points and explosion using the volume. So let's press start. And look at the sim, how it looks. So I disabled the guided object, use guides, and it's falling down again, but you can see the explosion very, very weak. So we need to increase the scale much more. So come on, cancel it and go down inside. Let's do I don't know, 50 for scale, and let's apply this again. So let me check. Yeah, it's working. That should works from frame 23, and let's look at that. And it's still not bad, but definitely need to make even more velocity. So press escape, get back to the first frame, and let's increase the scale for velocity, and let's connect our guide geometry so this ship shouldn't fall down. Come on, canceling. All right. So we're on manual mode, connect the guide sim and use guides. I don't know, let's keep those. Maybe choose the near surface mode. Let's select like 75. Maybe 100, something like that. So with the guide simulation, we have a few options. It's like a main setup, and also we have constraints. So we can remove intra-guide constraints, and we can select the group for the constraints you want to use. But in this case, which constraints I want to remove? I get that I want to remove constraints from my group other, like a small object. But again, we don't have this group for inside of my simulation. I use just my main frags. So let's keep it as it is, and let's say linear threshold, angle threshold like it was here. Okay. Okay. That's it. Let's look at the simulation. Let's launch again. And now we can see that it's working. Our ship is static now. It doesn't move anywhere. And we have an explosion. Maybe create a bigger scale for this. And bam. Okay. It's take a little bit more time with the preparation for a sim, because with the guided geometry to create different types of attributes and all other things. So let's press cancel. I press cancel. Okay. So let's tweak a little bit. Go to guides, or before we go ahead, I want to decrease the sub steps a little bit, maybe like 6x6, just for test. Create a little bit of a resistance, maybe to 15. And guided simulation constraints, and these two threshold. Okay, what I want to do, let's connect now all our elements. So in manual mode, I reconnected to all fragments, all our fragments. And I don't need those temp guys anymore. So I will remove them. Don't need this. And this is my guide geometry. We can set it like guide geometry. Can colorize this. Okay, let's drag it here. Let's put it there, just to make more visually better for us. All right, so okay, that's where that works. Let's look at the frame 23. I want to look at all my objects. Go to frame 23. It takes some time for calculation because it's gonna put many elements to the guided object. And I want to look at my ship, and then I want to separate some elements from the simulation. And here we go. It's a little bit heavy because of the big amount of small objects here, but it's working. Okay, so what I want to do now, I want to remove from the simulation my other objects. And how we can do this? Well, in fact, what I want to fix with guided simulation, there is a few things I want to do. The first thing is I don't want to guide my other group because there is a lot of small objects, very small, tiny objects, which I don't want to put into the guided group. So how we can do this? We can take all our objects from here, from my null, this is my geometry, and let's, oh, come on. Group, combine node. We'll go here. And I want to create guided group, which is all but. So I want to take all my objects except my small fragments. So if you look at our geometry, let me update it. If you look on our geometry, we have where you are. Okay, you have a name here. All right, and let's do over the points. And we have a small antenna, small gun, small main, and small piece. So small pieces. This is a group for the other object. So if I type here, if the name will be equal small pieces and the star. So it means that small pieces and then any name before. And if I will add the blast node, and let's choose, let's type guided here, let's update. So go to scene view, let's update it again. All right, so now we can see that I select just guided groups. Sorry, just other groups, so small elements. So if I press delete non-selected, it means that I'm gonna keep just elements with the guided group. And there will be all other geometries. So in particular is our main geometry, which was here on the test, plus guns and antenna. That's it. All right. And now with the RBD bullet seam, I will select and say that I want to use guided group for S guys, because I don't want to use them other group. It's very small element there. And also what is important here, if you look at constraints, where's my null object? Constraints. You can see that there is a few different constraint types. Go to here. So we have the all constraint. Where's my name? Constraint name, name, metal type. Okay, constraint name soft. And somewhere here we have a groups. It's a propagation, the name. So let's get back to my RBD and let's look at the constraints I have here. So I have in the guided simulation ability to remove interguide constraints, and I want to select the group. You can see that is constraint primitives to be evaluated for breaking. So which constraints I want to break? I want to break my metal to static constraints, the white ones, which we created the last time. And also I want to break the other constraints. And the other constraints, as you remember, is constraints in other group. All right? That's what I want to use here. Okay. So let's visualize the guided objects. I don't need to show constraints for now. And also with the breaking threshold, I want to add another one breaking element. And I also want to add the metal to static and the other constraints here for breaking. Let's set like a distance threshold to 0.1 or even 0.05, maybe like that. Okay, let's correct. Let's maybe increase the substeps to like 7 by 7. It should work. And let's see, add an explosion. Go to main cam, but I want to, let's just from the static position. I don't want to have a shaking camera for now, just to better visualizing explosion, fragments, and all this thing. All right, so creating flipbook, and we will see our explosions.